All right, hey everybody. This is a project or assignment called Tollbooth. It is very similar in a lot of ways to that Tech Rocks bridge. So the whole point, this is what I built, but the whole point says the local airport needs to place a toll booth at the exit. One sensor will be needed to open and one to close. So same thing, two sensors, just like the bridge. A red light should be on when the gate is down or moving. So pretty much when the gate is down or moving up, the red light should be on. And then when it gets to the top, it should stop. And then the green light should be on. Well, that's just the bonus, but we're going to attempt the bonus. So if you look at the build, you have a motor here going through. There's a shaft obviously going into the motor because that's how it works. There's a gear screwed on or going through. The shaft is going through a gear, and then screwed onto the gear is this arm. So then pretty much as the shaft moves, the gear moves, which makes this move. And similar to the Tech Rock Bridge as well, we put a potentiometer on it because it's going to go up until the potentiometer reads a certain number, and then it'll stop. And then it'll go down until the potentiometer reads a certain number, and then it'll stop. So it's very, very similar. The only difference is that you need lights. So if you look at the Cortex, hopefully nothing falls off. The Cortex, it has analog. That's the one lonely one over here. And then motor, there's only one in motor. Well, this is analog actually, and that's motor, but there's one in there. And then for digital, we have the two bump switches and then the two lights. So if you look at the code so far, motor and sensor setup. In digital, we have the red light, the green light, open and close bump switches. And they're VEX LEDs and then touch switches. Analog, the only thing in analog is the potentiometer. And the only thing in motor is motor, which we named motor 1. I named the potentiometer turn. Again, similar. This is a basic code I wrote, but we're going to have to make some tweaks. So until bump, meaning until you hit the open bump switch, then start the motor, and it's going to start. I didn't change the speeds for either one of the motors, so one of them is going to eventually have to be negative. And then you wait, and it keeps, so the motor's going to keep going until the potentiometer is greater than a certain number. And I just left dummy numbers there, so we're going to check it right now. So right now, I wrote this code, and we're going to check what numbers we should do in the debugger. So right now it is, okay. So really, we're going to have to go less than. So over here, when it's up, when the thing is totally up, the potentiometer is 2890 something. So this has to be changed to less than this number. I'm going to write 2900. And then on the way down, oh wow, okay. So it seems like this is a bit overturned. So this might cause us some problems, but whatever, greater than 4094, because I think the highest number is 4095. So we'll do that and stop motor. Okay, now we just got to see if it spins in the right direction when we click the button. This is going to be one of those things where you're going to have to stop it right away. So I think this is the start button. Good. Then hit this. Oh, okay, yeah, so that makes sense. Because the motor on the way back, I didn't change it to negative. And I'm actually going to speed it up on the way down so that we have a better chance of it working. Okay, so now everything should work. It should go up and down, and then we'll figure out the lights after that. All right, so let's see what we got. Click start. Good. Nice. Okay, perfect. So it works. Notice that I kind of had it slam shut because on the way down, I think it would have hit the number and it would have stopped a little short. Okay, so that part's working. Now we need to figure out the lights. So right away, we're probably going to want to get the lights on. So special, turn LED on. And this will be red. Turn LED off. That's going to be green. So that's going to stay like